Hello and welcome to Unit 1.1 Video 2 for Mr. McGee's 9th grade biology class at Arizona School for the Arts. This video series follows the biology coloring book by Robert D. Griffin. In this video, we are going to take a look at the scientific method today, which is coloring book plate number 3. Before we get too far, let's start with a definition about what science is. I use a specific definition in my classes that I'd like you to know. Science is an investigation into the natural world that uses empirically based hypothesis testing. And I've highlighted the words natural world, empirically based, and hypothesis testing so that we can take a look at these in the next few slides. What does it mean to be part of the natural world? In science, we describe something as being part of the natural world if it can be measured and quantified, or if it can be observed with the senses. But this does not include ideas or beliefs or morals, so we might consider those to be outside of science. These islands are part of the natural world. So is this hummingbird and the snake that's about to eat it. And this frog, also part of the natural world. And here's a confused monkey in the natural world. And this baby panda, also part of the natural world. But the natural world does not include ideas like justice, or peace, or music, or ghosts, or even love. None of these things are ideas that we would use science to try to understand. When something is empirically based, it means that it uses data that is collected through measurement, experiment, and observation. Hypothesis testing is something that humans do almost naturally. In fact, here are some children apparently doing some hypothesis testing. A hypothesis is simply a possible explanation for what is observed. Hypothesis testing is just a matter of performing an experiment. The scientific method is the process that scientists use when they make discoveries about the natural world. And your previous teachers may have presented the scientific method to you in lots of different ways, but I'm going to try to simplify it into 4 general types of processes that all add up to one overarching process that all scientists use. We're going to divide it into initial observations, questions about causation or mechanism, hypothesis production or the production of multiple hypotheses, and testing through experiment. So science begins with initial observations. This child is making some observations. As you can see, he, or possibly she, I'm not sure, is looking at these mushrooms. So, in other words, it is using its senses, or sometimes technology, to collect data, to make observations. Just a quick question, do you think that the observations that scientists find most valuable are qualitative or quantitative? Science also uses a process of generating questions. Most of the questions that scientists use involve causation, which means why does an event occur, or mechanism, in other words, how does a process work? A hypothesis is a possible explanation for what you observe. And a good hypothesis describes the causation of an observation or the mechanism behind it. A scientist generates competing explanations, and in order to find out which one is true, he or she tries to rule the others out. An experiment is how you test a hypothesis. A good experiment generates useful, specific, and measurable predictions. It attempts to rule out competing explanations to find the most likely hypothesis. That's the end of this video. Please complete the corresponding review questions and be prepared to show your notes to me in class. Thanks, and have a great evening.